Hello everyone, I'm Armen. I work as an MLOps engineer at Portmind, and today I'm going to present about our journey of building an internal machine learning model serving library, which has helped us a lot to improve our ML deployments. And here is the agenda for today's talk. So we are going to go over the historical context of our problem. Then we will talk about the challenges we faced at our company and what motivated us to create this internal tool. And I will present the design principles that our tool is based on, its features. Then we will take a look at a simple example and finalize by talking about the benefits and the impact of it. So our company had developed more than 10 machine learning models and services, and each was developed by a different data scientists. And we know that data scientists each has their own code style, and so as a result we had multiple services, each with different design patterns, architecture, web and validation frameworks, testing and logging monitoring, and also the deployments were different. So we had different styles for Docker files and deployment scripts. And all of this actually could have been common, but they were very different, which led to, so we faced many problems because of this. And yeah, we had challenges in our deployment processes. As a result of these differences, we had delays in our deployment, so we could not ship our models fast to production. And because there were so many services and our team was small, it was not so easy to manage these different applications and their deployments. So this was not scalable solution for us as the number of services increased, and there was no standardized way to handle all of this, which was caused a lot of headache. And as a result of this, our teams, both data scientists and engineers, they spent lots of time to investigate issues related to deployment, and yeah, instead of focusing on valuable work and improvement. And yeah, this was not efficient solution. So this motivated us to create our internal tool, because first, yeah, we need to solve these technical issues that we faced, and which will enable us to be more cost efficient, so that data scientists and engineers will spend their time on more valuable work. And there was also a business impact, because being more optimized in our processes and workflows would allow us to keep up with the competition and get more competitive advantage. And also we by improving our processes, we could deploy our models fast to production and get feedback fast, and yeah, iterate over our models better. So we gathered the requirements, identified the common parts of our services, and designed our tool based on the following principles. So first, it needed to be scalable, because we had many different services. So we would need an easy way to serve and deploy these multiple models and services in an easy way. it should be flexible because like each machine learning problem and model is unique in its own nature. So like the solution should be flexible so that we could adapt to these differences, and it should be like easy to use, like data scientists should be able to use it easily, like without like deep knowledge of DevOps best practices or like web serving or any other engineering or operations related knowledge. And it also had to be like reproducible so that we could reproduce our containerization of services and deployments. Extensibility will allow us to work on new problems without, and building new models and services without introducing any significant changes to our code base. And we also kept in mind that we need to be like build a tool that is always compatible, so that different models and services can always work with this tool, so that like we could roll out new changes, new releases, and like different services will work without any disruption. So we built a kind of a set of libraries and services, and like they consist of the following components. The first one is the serving library, which is basically a library that allows us to turn any like inference function into an API endpoint with a very simple interface. And internally, this library is called at our company YAML serve, which stands for yet another machine learning serving. The second one is the build tool, basically, which we use to like build, run, benchmark, or publish the images of our services. And we call this YAML flow. The third and fourth one, like they are about logging and monitoring, because this is really important for us to see how our models behave in real life, also like how our services behave. And so we build a service that will capture or serving data of our services and like store it in a database. And this is our YAML log service, and we used Prometheus and Grafana for system monitoring and alerting. And so YAML serve is our ML serving library, which basically includes all the like common web serving and web serving related common components of our services. It provides like the goal was to build a library that will provide very simple interface to turn any function into an API endpoint, so that data scientists would easily, like the only job of data scientists would remain to write an inference function for their developed models. And as a result, we wrote less code. Like we had separated created a new layer for serving, and it allowed us to have easier testing and maintenance of this part. And like we had also common web framework, validation framework, and like we could change any of these components in one place, and like all the other services would only need to like update their library version, and we'll get the new updates if needed. And also, like this yeah, this enabled us to be more efficient in our workflows and pipelines. And like we also like had the separation of responsibilities. So like engineers could work on this part, and data scientists could work on model research development. So there will be no blocking or disruptions between the teams. And yeah, the second one, YAML Flow, our CLI build deployment tool. It basically includes these 5 commands, and the goal here is the responsibility is to like orchestrate our model service deployment processes. So basically we have these 5 commands: benchmark, build, clean, publish, run, and we can use them to like build our machine learning services, run them, benchmark if we need, and publish them to our registry. And these operations are actually, they are based on some conventions which are very intuitive, but we also try to be flexible here. So these operations accept lots of parameters, and we can make them adapt to any scenario. The third part is our logging service. So we built this internal YAML log service that would capture all serving data and store it to logging storage. And yeah, here is the diagram that shows this architecture. So like each service sends its request response, like all serving data to this YAML log service, and it stores the necessary information to logging storage. So this would, we understood that it is necessary for us to have a single point to store logging instead of like multiple, like each service doing it on its own. And this orchestration part, like sending requests to YAML log, it was basically done in YAML serve. And yeah, so like we'll see it in a moment, like in the example that data scientists, like when they are trying to serve their models, they only need to like turn it on or off by just a flag, and like everything else happens like under the hood. And yeah, we used Prometheus and Grafana for our systems monitoring, and basically like the situation is very similar to logging. Like Prometheus pulls all the data from these different services if needed, and we used like Grafana to monitor our the performance of our services. And this is again like very easily handled by the serving library YAML serve. And yeah, here is a like very basic example of a service. It's kind of a toy example, yeah, but it allows us to understand how our serving library works. So we basically need to like define our function that will do the inference. Here it is like the predict function in the predictor, and like the user of our library will just need to define a service, and in the service define a list of endpoints that like should become an API endpoint. And yeah, so it is very easy interface to serve ML models, and we can see that like where we, for example, include monitor, logging, flags. So they can just turn it on and or off, and yeah, they will have monitoring or logging. And yeah, for when we have this service, we can use YAML flow to to basically build an image of our service easily. Here, like in the first command, we build a Docker image of our service by providing a tag and Python version. Then we can run our service. If we need to do some performance checks, we can benchmark it by providing a sample of requests to our service. And yeah, if we are satisfied with the results, we can publish our this image to our container registry. And yeah, we use these commands in our CI/CD pipelines to easily orchestrate the deployment of our services. And this, here we only used tag and PyVersion parameters, but these commands actually take a lot of different parameters so that we can easily customize them. And yeah, so to sum up, we can talk about some benefits and the impact that it had on our company. So basically, as a result of this, we removed thousands of code lines from our different code bases from different services because we extracted it to common library. We provided very simple interface to serve and deploy our models, and as a result, we had we reduced the number of issues we had in our deployment. So we started to deploy and release to production fast, and actually this resulted also in efficient use of our resources. So data scientists could focus more on model research, model development, and yeah, engineers could also do the same thing, focus on the actual work that brings more value. Yeah, also as a result, we had this standardized way of model serving and deployment, and it was separate from all the other components, so we could improve it separately, without affecting all the other parts. And yeah, so the key takeaway from all of this is that if you face a similar problem, you have different many machine learning models, it is worth considering this kind of solution. Thank you.
I would like to ask about the product metrics of your stuff. So you told us a lot about it's more easy, faster, better, and so on. But actually, what are the metrics? What's your goals after implementing this thing? For example, how does it affect the lead time of the models? Do you measure it, and so on? Please tell us.
Yeah, actually, we thought about that. So by separating this part, serving part from from the model, we created this separate layer where we could also improve the performance of our serving if we wanted, in a single place. Yeah, but also as a result of this, we the deployment part was a lot faster than before, because beforehand we had different deployment scripts, and it was really complex to deploy all these services.
But isn't it some kind of bottleneck for your teams? For example, they could be more creative and faster if they are smart enough to do the certain part by themselves. But now you are giving them a tool Are they confident that it's okay, everything is good with performance, and your team resources isn't a bottleneck to them?
Yeah, so yeah, in our situation, we like this worked better than like the other part. Yeah, so it in our case, it was not like our team was satisfied with the solution because like they like data scientists, they only wanted to do like their research. They didn't want it to like.
Product metric data scientist is happy.
Yeah.
Studied like that.
Yeah.
I have a question about, do you have any plans on like optimizing storing, paralleling requests, or using multiple GPUs at the same location?
Yeah, actually, we have a like in our vision that like because this is a separate library now, we can like focus on more on performance, and yeah, we have that in our roadmap to improve it and make it better.
Why did you decide to write your own framework when there is some industry-grade solutions like the original MLflow?
We like researched the industry and like this like came to the conclusion that all these solutions, they didn't like satisfy our needs. So yeah, basically we needed to have our own solution, which will be like very easy to use. Yeah, like in our all the existing components, I think like they didn't solve our problem the way that we did. So yeah, we wanted to like to be very provide very easy and like simple API like interface, and yeah, that's why we wanted to build our own solution.
Okay, I guess you maybe could make a wrapper around some existing framework to simplify interaction with it. But in general, there is a lot of inner machinery, like you have the registry, you have some serving, some uploads. This could be simplified maybe. But for your case, yeah, it works if you want something simple.
Yeah, it's actually a good idea to like write a wrapper around the existing solution. That's actually a good idea, I think.
My question is, are there any similar tools available? So even paid ones, so like graphical ones you can drag and drop. So
actually, like there are similar tools, but I'm not sure if they are particularly like targeted for this machine learning problem. For example, there is a like Jib for like it's for Java applications, I believe, that allows to. It's actually like our CLI build tool that allows to like build containerized images in a very easy way. But I'm not sure like it's not targeted for this specific case. Yeah.
do you have some kind of experiment tracking, or could you call it something new for that?
Yeah, actually, currently, like we don't have a like good solution for experiment tracking. We are still like researching it. Yeah, we are in our this system. We don't like have any kind of experiment tracking.
Is there any way that you save the models and the request that they save? For example, since we don't have an experiment tracking model, I would like to see the model that was trained, the hyperparameters it was given with some metrics. So do you store them in some kind of way, or is that just the response of
Actually, currently, like it's kind of like we keep documentation about like the model that was trained and all the information about that, and yeah, it's not included in this system. We don't like capture the data and store it like this model was trained and it's served in this kind of ways. So yeah, we don't have that information right now, but we are actually thinking about that to like make the connection between all of these components.
So if you train a model during an experiment and then you decide to go with one architecture, you would have to train it again and then save it.
Yeah, I believe so.
I think the thing that was mentioned was about like model performance monitoring, like monitoring the model and the service as a machine learning model and not like as a service. But I think this is a good extension and this is a good step. Can you tell us about like key challenges that you had with versioning? We know that like keeping all services up to date is kind of challenging. What was like key takeaway in this journey?
Yeah, actually, yeah, it's a good question because we talk about all the benefits of building this service, but yeah, when you have like 10 or more services, they are like all different. It's not so easy to like. Actually, there is a common part, but it's not so easy to like write a single solution that would satisfy all the needs of these services. So yeah, it was really challenging. So we were like iterating over and over again to satisfy all the requirements of these services. And yeah, that's why we try to be as flexible as possible. And actually, one good thing also was the like collaboration between like engineers and data scientists. So it's always, I think, important to keep this collaboration because, like, at the end of the day, data scientists are the users of this like library, so they will provide more valuable feedback, like how it could be improved. Also, yeah, about the versioning, we like always try to make like backward compatible changes, but sometimes, yeah, we had cases like new business needs or no requirements that we could not integrate into our like current solution. So we needed to like make major changes. That was really challenging when you make a major change in a library that like needs to be integrated in lots of places. Yeah, so it was a challenging part as well.
Seeing that the logging part was with the flag, have you considered like it, or maybe I'm wrong, are data scientists able to like write console logs, and have you thought about like a logging format so that it is easier than to parse and make some analysis?
Like in our current solution, we have a like very easy way to like transform our request response, like all the information to the format that we could store in our logging storage and then like gain insights. Initially, we wanted to like provide this way to data scientists so that they could write their like parsing functions or some stuff like that. But yeah, then we decided that it will be like more easier or better. Actually, there is no like I think a single solution that will fit all the cases, but we came to the conclusion that we would like take this burden like from data scientists.
What about input validation? Have you considered that?
About like a request. We actually provide this interface to validate request inputs.
Thank you.
Thank you.